Now we want to try this in the playground, and we won't use the publicly available playground because that's outdated. That's from February, I believe. We want to use one that is in sync with the version of Plutus we are using right now. So we go back to the Plutus repository in a Nix shell to the subfolder Plutus minus playground minus client, and we start Plutus playground server there. Then we go to a different console, but the same folder again in the Nix shell, and we do npm start to start the playground client. And then we can open this address in a browser and find our playground there. So first we will see the editor window where we can paste Haskell code. So there will be some example code there, so we can delete this and instead paste in our auction contract. There's one thing we have to do. We have to remove this module header. Now we can click compile, and once compilation has successfully finished, we can click on simulate. And now we can set up a scenario, and we see that we have wallets. We can also add more wallets. We have some generic functionality, so we can send assets from one wallet to another. And we have the 3 endpoints we defined for our auction contract: bid, close, and start. So let's try to recreate the scenario that I showed you in the diagrams when I explained the example contract, or something like it. First of all, let's set up the wallets. So this is in Loveless, so 1 ADA is a million Loveless. So if you count zeros, then you see that here by default, these two wallets have 100 ADA to begin with. And they also have 100, or actually 100 million of this T token that, if you recall, I defined at the bottom of my module to have something. So that's supposed to be the NFT that's being auctioned. So it should only exist once. So let's say wallet 1 has that in the beginning, and it only exists once. So there's only one coin and wallet 1 has it. And to make it more interesting, we should have at least 3 wallets. So the owner of the token and then 2 bidders. So let's add a third wallet and also 0 for this token T. So the token T here represents the NFT that we want to auction away. So we should start with the start action. So wallet 1 should start the auction. So let's do this. Let's worry about the parameters later. Let's first set up all the actions. So next we should wait for 1 slot. Then let's say wallet 2 makes a bid, and we wait for another slot. Then wallet 3 makes a higher bid. Then we wait until the deadline is over. That's up to us what the deadline should be. Let's say something like 10 slots, which of course is not realistic because a slot on Cardano is just 1 second. But for this simulation, that's fine. So let's say we set the deadline at 10, and just to be safe, we wait until slot 11. And then somebody calls close. So that could be the owner of the token, so wallet 1, or the winner of the auction. Doesn't matter, let's say wallet 1. And finally, we have to wait another slot to give the transaction time to be processed. Okay, so now we must fill in the various parameters. So, and the first one already is a problem because the deadline. And I will explain that in much more detail in a future lecture, the time handling in Plutus. But just briefly, so as you can see, the simulator, as you see with these waiting actions, is based on slots. But time in Plutus is actually not handled in slots, but in real time or POSIX time, milliseconds since 1st of January 1970 or something. So we somehow have to put the right value there that corresponds to 10 slots. And without wanting to go into any details, there's a Plutus module called ledger.timeslot that has various functions related to time. And one is slot to end POSIX time. So given a slot, it will give us the corresponding POSIX time, or rather the POSIX time that corresponds to the end of the slot. And in addition, we also need a so-called slot config. So that basically says when the blockchain starts. So it contains the length of a slot and the POSIX time of the first slot. And the playground works with the default slot config. So we can use the REPL to do the calculation. I need to import two modules, data.default and this ledger time slot. And now I can use this slot to end POSIX time. And as slot configuration default, so this DEF comes from this data.default module. And now a slot. So we set 10, so let's see. And we get the corresponding POSIX time in the playground, which is this number here. So that should correspond to the end of slot 10. So back in our playground, we can use that as the deadline. So everything else should be easier. So the minimum bit, that's up to us, let's say 10 ADA. So 10 and then 1, 2, 3, 1, 2, 3 zeros. Now the token that's been auctioned. So we need the currency symbol and the token name. So for some weird reason, if you recall in the code, I defined it as F, but in the playground that corresponds to 66. Don't ask me why. Some hexadecimal conversion, I assume. And the token name is T, but that doesn't matter. Right, and so for the bit, we again, in order to find the auction, we need to name the NFT. So that's always this 66T. And now we have to quantify the bit. So let's say wallet 2 starts with the minimal bit, so 10 ADA. And wallet 3, same thing. First the token, 66 and T. And it must be a higher bit, so let's say 15 ADA. And finally for the close, again, we have to repeat the NFT. And that should be that. And now I can evaluate. Okay, and we see the result. And it's displayed in quite a nice, intuitive way. So especially for beginners, I think that's quite pretty and useful. So here we see the transactions that happened. So if you recall, we did the start, 2 bits, and the close, so which is only 4, but here are 5. The reason is that there's always a so-called genesis transaction where the wallets get their initial funds. So the first we see here is this genesis transaction, which doesn't have inputs. It's basically the start of the blockchain. And we see that our 3 wallets, which are ordered 3, 2, 1 here, get the funds that we specified as initial funds. So wallet 1 gets the 100 ADA and the token, and wallets 2 and 3 get the 100 ADA. So that's not very interesting. So let's look at slot 1, the first transaction that we explicitly triggered, the start of the auction. So the input is this UTXO, that the only UTXO that wallet 1 owns. Its initial funds, so the 100 ADA and the token. And we see there's some fee, which in the playground is 10 Loveless, which in the real world, on the real blockchain, will be different, will be a bit higher. Then there's a change output going back to wallet 1. And then this one is the interesting output. That's the one to the auction contract. And we see the token goes there. We also see that 2 ADA go there. I mentioned that briefly before. On Cardano, there's the rule that every UTXO must contain some minimal amount of ADA. I don't know exactly how high it is. It's probably a bit lower than 2 ADA, but just to be safe, I hard-coded that basically into the code to use 2 ADA for this. Okay, so the auction has started. Now this should be the bid by wallet 2 of 10 ADA. So we see two inputs, the initial funds of wallet 2 and the auction contract, the script output. And again, a fee, some change for wallet 2, and again, the script output, which now still contains the token, but now the bid of wallet 2, which was 10 ADA plus the 2 that were there originally. So the bid of wallet 2 has been added to the script output. Now comes the second bid by wallet 3, 15 ADA. So that looks similar. So wallet 3 funds and the script output. And now the output side is a bit more interesting. So fee again, change output, the updated script. So now it's still the token in there, but now the 15 ADA bit plus the 2 that were there in the beginning. And wallet 2 gets its bit back. So the 10 ADA are refunded to wallet 2 because wallet 2 has been outbid. And finally, in slot 11, when wallet 1 called close, the script input, then wallet 1 funds, and as output fee, change for wallet 1. This is the highest bid that wallet 1 gets, so the 15 ADA. And for that, wallet 3, the highest bidder, gets the token. And also this minimal ADA deposit that was in the UTXO to begin with, the 2 ADA. So the auction has successfully closed. Recall there was the second path if nobody bids, so we could, if we wanted to, briefly do that as well. So we can do a second scenario if we like. So in this case, we don't need a third wallet, but let's turn this into an NFT again. So there's only one T. Let's say again, wallet 1 starts it. Is that still in my, yes, lucky, it's still in my clipboard. So let's say same auction basically. So same token, FFT. No, sorry, it was 660. And now there is no bid, so we just wait until slot 11. And now wallet 1 should be able to get the token back at least. And we wait for another slot. So 66T. Let's see whether this also works. Okay. And we have fewer transactions, but it looks good. So this is again the genesis, the initial transaction that gives the wallets 1 and 2 their initial funds. Then the auction starts as before, so that should be the same. So we have the script output, the auction contract with the token and this minimal deposit. And then nobody makes a bid, and after the deadline, slot 11, the script output just goes back to wallet 1. So wallet 1 ends up with the token again. So we see that the playground can be used to actually try out smart contracts that we have written. And I think it's quite a pleasant user interface, and it's very nice to get a feeling for how these things work and get a better understanding for the UTXO model with the inputs, outputs, and so on.